Hello everyone, let's start with another topic of module 3 symmetrical components. One derivation will be there. Prove that the balanced set of three phase voltages will have only positive sequence components of voltage only. So this is your symmetrical components phasor diagram. So VA, VB and then VC. Just I considered conductor will move BA, BC. I mean A conductor, B conductor and then C conductor. I just considered anti-clockwise direction. So if you want to consider clockwise direction, it is also possible. You can consider a clockwise direction. So let VA, VBS are the balanced system three-phase voltages. VA and then VB and VC are the balanced three-phase voltages, and VA naught, VB naught, VC naught or VA naught, VB1, VB2 or VA naught, VA1, VA2 are symmetrical phase sequence components. This is a negative sequence, positive sequence. This is a zero sequence, zero sequence. This is positive sequence, this is negative sequence. And so VA is equal to VA. VA have taken reference, figure 3.3 is our reference voltage. VB, if you want VB, so we want 240 degrees, so A square, that's 120 plus 120, that is A square, 240 will get. So VC is equal to only 120, so AVA. A, this one is 120 plus 120, I mean there is a phase difference 240 in the sense A square, and if it is only 120, this is a A. So we got the equations as taken as 1. So this is a VA0, VA1, VA2. Already we know, right? 1 by 3 A phase sequence components in terms of symmetrical components. So VA0, VA1, VA2, 1 by 3. This is I substituted VA as VA, and then VB is equal to A square VA, and VC is equal to AVA. I have taken from the equation number 1. Just you keep it in your mind. So just you multiply this into this, you will get the equation matrix like this. So A cube is equal to 1, A square is equal to A. Already we know that A operator. So we got the equation as 1 by 3 VA into 1 plus A square is equal to what? 0, and 3 value 0 will be there. So you will get only 3 VA. So 1 by 3 into 3 VA. 3 will cancel into 3 VA, so 3 cancel, we will get VA only. So let's see how exactly we will get it. So 1 plus A square, 1 plus A square, from the J operator we got 0, and then this is 1 by 3 into 3A, so VA0, VA1, VA2 is equal to VA. So comparing the terms of we obtain, VA0 is equal to 0, this is the zero sequence component, VA1 is equal to positive sequence component, VA0 is the negative sequence component. So the theory question itself indicates what is that? Prove that balanced set of three phase voltages will have only positive sequence components. These three voltages, these VA, VC balanced voltages having only positive sequence component. Only VA will be there, VA will be there, only VA will be there, and there is no zero sequence, there is no negative sequence components present here. Okay. Let's solve one problem of our third module, that is determine the sequence components three phase voltages. VA is equal to 200 angle 0, VB is equal to 200 angle 245, VC is equal to 200 angle 105 degree. So we know that the equation of VA1 is equal to 1 by 3 VA plus AVB plus A square VC. Already we know. So from that I'll substitute the values. 1 by 3 into, so I substitute the values of all the given data. So VA, VB, VC you substitute, and then we will get the phase sequence component. Determine sequence components. So these are the VA, VB is the phase voltages. So you can determine phase sequence component. That is positive sequence, negative sequence, zero sequence. So V8 is equal to this equation. So 1 by 3 into a VA plus a square will be a VC. So already we know, right? So VA naught VA1 VA2 is equal to 1 by 3 into 1 1 1 1 1 a square a square. Already we know that is VA VB VC, right? Okay. Next, we got the value as 20.15 angle 158.3. So if you want VA naught, so how to calculate VA naught? So VA naught is equal to 1 by 3 VA plus VB plus VC. Just you substitute the value of VA and VB and then VC, you will get the answer. So 21.6 angle 16.58. Okay. Okay. Just to remember this formula. This formula is very much important for calculation of sequence component. This formula is very important. This 1 by 3 and then this one VA VB VC. If suppose sometimes they'll give VA naught value, VA1 value, VA2 value, we need to calculate VA1 VB1 VA VB VC. So at that time we will be having formula like this. VA is equal to only VA naught VA1 VA2 into 1 1 1. There is no 1 by 3. Okay. That you keep it in your mind, and then you solve the problems based on the questions. Okay. Thank you.